Hey, physics. So Unit 5 here is going to be about energy. So we're starting Unit 5 about energy. But before we go and we talk about energy, first we're going to talk about work. Okay. Now, we're going to talk about work first. Work is very much related to energy. Work is the change in energy, and energy is the ability to do work. So kind of circular definition there. But in our first lesson here, we're going to talk about work. So we want to be able to describe the work done on an object. So let's go ahead and talk about that. Okay, a few things to know about work. When we talk about work, we use the variable W, that's a capital W, for work. The units for W is something called a joule. It's named after the scientist James Joule. Joule is abbreviated with a capital J, that's Joule, Joule. That's the unit for work. It's also the unit for energy. So as we go forward and we talk about energy, keep in mind that Joule is the unit for work. It's also the unit for energy. And we can calculate the work done on an object by taking the force that's applied to it times the distance that it moves under that force times the cosine of the angle between the force and the distance. Force and the distance are both vectors, and so there's an angle between them, and that's the angle we're talking about there, right? So something to keep in mind about work is there's only work done on an object when you have both a force applied to it and it moves some distance. Okay, so for example, I can push on the wall. I can apply a force to the wall, but the wall doesn't move. So was any work done? No, because D is 0. There was no distance. Similarly, if I have, let's say, an asteroid floating through space at a constant speed. If it's moving at a constant speed, it's going to cover some distance. But there's no force applied to it, right? So in that case, F is 0. So was any work done? Nope. So in order for work to be done, you need both a force and you need a distance. So one thing to understand about work is that its sign is important. It could be a positive, could also be a negative. Consider what it means to have a negative work. Let's say I have a car. Let's say you're driving along in your car, and your direction that you're traveling is this direction, right? This is the direction that your distance is. And then you go ahead and you apply the brakes. And what do the brakes do? Is they apply force in the opposite direction. Okay. Now that force is in the negative direction. So when you multiply these numbers, that one is a negative, right? So you're going to end up with a negative work. So a negative number times a positive number is a negative number. So you're going to end up with negative joules of work there. And so what does that mean? That means that my car is going to slow down, right? It's going to move. It means the force is applied in the opposite direction that it's moving. Okay, let's have a look at an example of a problem we might see. Okay, problem, it says how much work is done on a vacuum cleaner that's pulled 3.0 meters by a force of 50.0 newtons at an angle of 30.0 degrees above the horizontal. Okay, so it's fairly simple. The first number tells me there 3.0 meters. That's the distance. And then it tells me that the force is 50.0 newtons. And finally, it tells me that the angle between them is 30.0 degrees. Okay. So I'll just put the numbers in the equation. So that's 50 times 3 times the cosine of 30. And then let me grab my trusty calculator. I got 50 times 3 times the cosine of 30. And I need two significant figures because 3.0 only had two significant figures. And so I'll round this off to 130. And what unit should I put on that? Of course, for work, will be in joules. So there's a little bit about work. We did an example there. We talked about work. Remember, the unit is in joules. Force times distance times the cosine between them. Hopefully that helps us be able to describe the work done on an object. So until next time, take it easy.